Hold on. That is 59.
So we're just gonna use this for our next class. So we're just gonna
It's all over but the last part. So that way we can try to put the last part together.
That's a lot. You don't even tell you the truth. Get it off for you.
I don't think I'll put the aim in. What do you try your best? I mean, I feel good about it, but like I'm never gonna like get this high. You're never gonna be like, I don't think that makes sense.
Yo, Jacob. Yeah. You do anything last class after the test?
No, they didn't. That was just the test whole time. No. I don't understand why you're so confused, Samantha. I don't understand. Why? Nothing. Not even a little bit. Why are you standing like that? Oh my god, there's no way. That's 200 inches. That's that. All right.
Both the handouts you guys picked up today together make up 49.
What do you think I did?
Lucas. Yeah, both of them make up 49. I'll see it again. Okay, so we actually have one more section out of the textbook that we do this semester, and the rest of the stuff that we do this semester is review and to go back over some of the stuff that's a little bit harder. So the last section that we do is section 5.3 in the textbook. However, we're kind of in a weird spot where we have 4 class periods, I guess 4 if you count today, before Thanksgiving break, which would be probably around the correct amount of time to finish section 5.3, but B-Day only has 3 days. So we don't have time to get 5.3 in before Thanksgiving break, so we do that after Thanksgiving break. But part of what you will need to do in section 5.3 is be able to solve some equations, and one of the things that sometimes holds students back is factoring. So in our last couple days between now and Thanksgiving break, we're going to do some factoring. Factoring is the only thing we're going to do today, but we'll practice some more factoring and do a little bit of the semester test review, and then that way when we come back from Thanksgiving break, we can hit the ground running with section 5.3. So today we're going to focus all on factoring. We're going to take a little bit of notes here on the front page so I can just remind you of the major types of factoring. Just give you a quick little refresher. Should not be anything new there. I'm going to relate it to trig so you can see how we're going to use it and how if you can factor algebra stuff, you can factor trig stuff. And then on the back page, there is 10 questions I will ask you to factor. So we should have plenty of time to get this finished in class and not have any homework. Okay, but to start off today, we are GCF. Greatest common factor is one type of factoring that you need to be able to do. In fact, you should always try to do this first if possible. It does make the questions a little bit easier. And to me, when I think of GCF, I just think of you're undistributing. So you're trying to figure out what's the biggest number that goes into both of these, what's the biggest variable that divides evenly into both of those, and that is what the GCF is, and you pull it out front of the parentheses. And then to figure out what's left behind, you just imagine distributing. So this times this is supposed to give me that, so it still needs a 4p, and this times this needs to give me this, so it needs a plus 1. Good with that? We're all on the same page now? Okay. So, for this one, the biggest number that divides into both of those evenly is -6. The biggest variable that divides into each of those would be r to the 4th. And then what would be left behind? What would have to go here? Okay, an r, because this times this needs to be this. And then what needs to go here, if anything? A plus 1, good. If you don't put the plus 1, again, you need to distribute your answer to make sure that it goes back to this. So, I don't know if you realize or not, well, I want you to try this one. I want you to try this one before we move on. So while you do that, I want to point out that factoring is really just undoing multiplication, and you guys have been doing that type of thing in mathematics pretty much the whole time you've been doing math. For example, you learned addition, and then right after that you learned how to undo addition. We call that subtraction. Then you learned how to multiply, and then you learned how to unmultiply, which would be division. Factoring is just a way to undo timesing, multiplication. So all of these factoring questions we're doing today, you could always multiply your answer to make sure it goes back to the original question. I'll pause for just a second here to give you time to finish trying this one. Again, just a quick little snapshot to make sure you know what you need to be doing there. let's make sure you got the same thing that I did. And I'm going to miss this question on purpose here for just a second because I think there's still some value to what I'm about to do. So first off, if you need a GCF for 3 terms, it's got to be something that goes into all 3 of those. So let's say that I can't think about what's the absolute biggest thing that goes into all of them. Sometimes just taking out something, like all of these are divisible by 5, taking out something and then reevaluating. Once these numbers get a little bit smaller, do you see how all of these still have a 2 that they're divisible by? So it's not that 5 was a GCF, it was supposed to be 10. But if you can't see that it's 10 right away, just pull out something and then look at the smaller numbers, and then I pulled out another 2, and then that's what you should have ended up with. Good with that? Okay, I feel like I may have said this in this class, but again, I think it's important for y'all to make these connections so that you can see that, you know, I can talk about GCF for a whole entire class period, and that's great. But sometimes you guys think, oh, I know how to do that. I've seen that. Honestly, that's probably one of the easier algebra things you've ever learned is GCF. But I do like to try to relate it back to calculus. So, and just randomly, here is a free response question we worked on last week. And what I want you to notice is that they had to solve this by hand without a calculator, this big messy equation. And the trick to it is the same thing that we just practiced. It's just harder to see. This big term, all of this stuff is one term, and all of this is one term. This term had a 2x plus 4 squared, and this had a 2x plus 4 squared. They had at least a 2x plus 4 squared in common. So, do you see how that GCF got pulled out? But even some of my calculus students struggle with seeing that. So, sure, you can do GCF, but as you guys move on into higher mathematics, sometimes it's hard to see. If this had that and this had that, you can pull it out front, and then sometimes that's what makes it doable without a calculator. So, nothing you need to worry about today, but GCF is important. And honestly, when we did this, not to beat a dead horse or anything, but this worksheet we did last week, we did 5 practice FRQs, and of these 5, my student said this was the hardest one, and it was because of this step, and it was just GCF. So, just to give you some perspective there. Okay, so we will need that today. We will also need to remember the pattern for difference of 2 squares. This one's very common. So the name kind of gives it away. Difference means subtract. 2 because there's 2 terms, and they need to be perfect squares. So traditionally, it usually looks like this. Something squared minus something squared. And the thing on the left being squared goes here and here. The thing on the right being squared goes here and here. And then these always factor as 1 positive, 1 negative. So when I look at this, there's something being squared on the left, something being squared on the right, and it's a difference. So a 4n plus a 3 and a 4n minus a 3. Okay, and then of course 1 is a perfect square too, because 1 squared is 1, r squared is r squared. So if you have something being squared on the left, something being squared on the right, and it's subtraction in the middle, then it's a difference of 2 squares, and it follows that pattern. Of course, other than the last 10 questions today, we could FOIL these together to see that it goes back to the original question. We could multiply these to see that it goes back to what we started with. Okay, I'm assuming you did a bunch of that last year. That's familiar? Okay. All right, sum of 2 squares. I don't have any examples down here, but let's just make one up real quick. So sum means add. 2 squares means they need to both be perfect squares. And the reason I don't have any examples here is because the sum of 2 squares does not factor, which traditionally we call prime. Anytime you have the sum of 2 squares, don't waste your time trying to factor it. In fact, if you think it factors, I encourage you to write down what you think it factors to, FOIL your answer together, and you'll see that it doesn't work. Difference of 2 squares has a pattern, sum of 2 squares, don't waste your time. Okay, and that leaves us with the other 2 types we're going to look at today, which is factor by grouping, which based on my first period class today sounds like you guys did do some of this last year, which is great. But typically you guys don't practice this often. But I will tell you that this factor by grouping is going to help us on the last method as well. So I know to try factor by grouping anytime I see 4 terms. So notice all of these have 4 terms. And it's called factor by grouping because you should group the first 2 terms together with parentheses and the last 2 terms together with parentheses. Keep this sign in the middle. A common mistake is students try to do this, and then that causes other issues. Leave the plus or sign or minus sign in the middle. If you see 4 terms and that light bulb pops up in your head that, hey, this is grouping, and you group the first 2 and you group the last 2, you can finish this question if you can do GCF, because it's now to finish this question it's just GCF 3 times. We can pull out a GCF out of the left 2. We could pull a GCF out of the right 2. And I really like this method because the third and last GCF, again, it's a little bit harder to see, but just based on what I showed you, how it appears in calculus, this is pretty common. This big term has an n minus 2, and this big term has an n minus 2. If they both have an n minus 2, you can factor it out as a GCF 2. So n minus 2 times this is supposed to give me all of this. So it needs a 5n squared. And then n minus 2 distributed to this is supposed to give me that. So I need a plus 3. This is what you could multiply together to get that original question. So if you can do GCF, then you can do the computation part of this. There is only one catch that makes factor by grouping a little bit harder, and we'll see that on the next question. So the next question also has 4 terms, so I know I want to group the first 2 and group the last 2. But I've got to do something else this time that I didn't have to do over here. So anybody got a guess what's wrong with this question that did not occur in this question? Right, this minus sign in the middle creates one extra step. Right here, if this is a plus 1, remember this is an understood 1, distributing positive 1 doesn't change anything. So creating these parentheses did not change the original question. But over here, when I put in these parentheses, now the negatives go into 56y, which gives us minus 56y, which is okay. That's what the original question says. But it's also being distributed to plus 8, and negative 1 times 8 is negative 8. You can see on your paper the original question doesn't say minus 8, it says plus 8. So as it stands, this is not equivalent to the original question. So you might want to write this in words, just a suggestion. But if this is a minus sign, you have to switch just this last sign. That way when we distribute this, it's equivalent to the original problem. So again, if you want to write that in words, I will pause for a second. But only when this is a minus sign, because now it's being distributed to this when it wasn't intended to, you need to switch just this last sign. If you are unsure if you did that correctly, you can always just quickly distribute it and make sure that the question hasn't changed. Okay, but other than that one thing that could happen, the rest is GCF 3 times. You could pull a 5 and an x out, you could pull an 8 out. Right before you get your answer, you should see that this has a 7y minus 1 and this has a 7y minus 1. If those are not the same, you know something's wrong and to check your work. For example, if you forgot to switch this sign, it's going to say 7y plus 1 and you're going to know to think again. But if these both have a 7y minus 1, we can also factor it out as a GCF. 7y minus 1 times 5x gives me that. And 7y minus 1 times negative 8 gives me all of that. This would be the final answer there. Group, the middle sign's a minus, you need to change the last sign. GCF, GCF, GCF. Okay, I would like you to try that one time for me, please, on this question. Just go ahead and try it and see how it goes. Okay, I'm going to cut you off here, so if that wasn't enough time, I apologize, but it at least showed you where you were slowing down, perhaps. Okay, so you should know this is factor by grouping, not just because this is where it is in the question. In the worksheet, but because it has 4 terms. So you should have tried to group the first 2 and last 2 terms. Because this is a minus and it's now being distributed, you need to change the last sign only. You need to take a GCF out of these 2, and this one's a little bit harder. Like I can see an A comes out pretty quickly, but between 105 and 90, I don't know. I know a 5 goes into that at least, so I'm going to start off with 5. That would leave behind 21b minus 18. Does that sound right? Okay, over here I could factor out a what? You could do 3 at least, which will be 7b minus 6. Okay, so over here I took out a 5 because in my head that's the biggest thing that I could see safely. But now that I'm looking at these smaller numbers, 21 and 18 have 3 in common. So I should have factored out a 5 and a 3. So again, you don't have to get the absolute greatest common factor on your first go. Sometimes just factoring out something to make the numbers a little bit smaller is enough to make it manageable. But then this term and this term both have a 7b minus 6, which is a good sign. The rest of your answer would need to be a 15a minus 3. And depending on how you're using this could be fine. But as you guys should be familiar with, most of the time in factoring, it's going to ask you to factor completely. Is there anything else I could do to make this factored a little bit better? One more time. By 3, is that what you said? Yeah, so right here, these two have a GCF of 3. So in a perfect world, you would have actually factored that out at the very beginning. 105, 90, 21, and 18 are all divisible by 3. So if you see that and you can pull that 3 out at the beginning, that makes the rest of the number smaller, makes the rest of the question easier. But if the question was to ask to factor completely, you would have to consider GCF at the end if you didn't consider it at the beginning. So, okay, so again, I don't know how much y'all practiced factor by grouping last year. It kind of changes year to year, or based on who's teaching it. So, does that all sound pretty familiar? We're okay with that? Okay. Then let's move on to the bottom part, and I want to spend a few more minutes here because these are the most important question types, just because they are the type that show up the most often, and that would be a trinomial. So factoring a trinomial, if this a value is 1, it's pretty easy, but if a is not 1, you need to have a couple methods to try. All of these, a are not 1. So I'm going to rely on 2 methods here, and I'm going to ask that you do the same thing for your notes. And then after we do these 3 questions, the way I'm going to ask you to do them, if you have a different method that you learned in Algebra 2 that works for you, then you are still welcome to use it. You don't have to use my method. But the problem is, to factor trinomials, there's at least a dozen ways to do them. So if you are relying on, I don't know, the washing machine method, did anyone ever learn the washing machine method? Okay. I don't remember how to do that method, so I couldn't help you looking at that work. There's just too many ways to factor, so I'm going to stick to this one. But before I get to that, guess and check is what you should always try to do first, because as you guys get older, go on to harder math courses, you don't want to spend 5 minutes every time you have to factor something. So guess and check is where we just try to unfoil it in our head. So I'm going to do guess and check just one time here, but of course my guesses and your guesses could be different. But I can see that the f part of FOIL is supposed to be 3p squared. So I would guess it's probably going to be 3p times p. The last part of FOIL is supposed to be -5. So I don't know. I would guess maybe +1 times -5. You should not circle that as your final answer, though, until you actually check your answer. And the way you check it is to make sure that the outer part of FOIL combined with the inner part of FOIL actually gives you -2p. Mine gives me -14p, so this is not the correct answer. But what I could do is I could move some stuff around, make sure that the first 2 multiplied together are still 3p squared, make sure the last 2 multiplied together are still -5. But now that I've swapped those around, now the outer part is 3p and the inner part is -5p, and those combine to be -2p, which is what I want. So, of course, the more often you do guess and check, the better your guesses are. They shouldn't be completely blind guesses. They should be educated guesses, but you have to mess with and tinker and tweak until your answer foils to what it gives you. So I always suggest that you do that first. The more often you do that, the more often you're comfortable doing that. That's what I do 99% of the time. That being said, when you need to factor this, like you take college algebra someday, there could be 10 questions after you factoring this. So if you can't factor it correctly, you can't just say, well, I can't do that page of my test. You have to have a backup method just because you couldn't get it with guess and check. So the method that I'm going to show you, the method I want you to write down on this page, but you don't have to use it after this if you don't want to, is called the product sum method. I like the product sum method for about 5 different reasons that I'll tell you as we go through here. But what does product mean? What does sum mean? Okay, sum means adding. Product means multiplying. Yes? You've heard that before? Okay. Okay, so the product part of product sum, and you guys may have learned it this way last year, I don't know. But the multiplying part is you need to find 2 numbers that multiply to whatever a times c is. And now when I refer to a, b, and c, it's the same a, b, and c as like quadratic formula. So in this question, 3 times -5 would be -15. So I need to find 2 numbers that multiply to -15. So sometimes I just make the list of everything that multiplies to -15. But I need it to add the sum part of the word to whatever b is, and b is -2. 1 and -15 don't add up to 2. -1 and +15 don't add up to 2. -2. But these 2 do. +3 and -5 are the 2 magical numbers here that are going to make this work out for us. Now, the temptation is, and this happens to a handful of students, where they say, okay, I've got the 2 numbers, I know what to do now. This is not part of the answer. I would love for it to be, but that doesn't mean that your answer has a +3 and a -5. You can foil that together to see that that doesn't work. What these 2 numbers tell you is how to rewrite the question and how to rephrase term B. So I'm going to leave the A stuff alone. I'm going to leave the C stuff alone. But instead of saying -2p, I'm going to use these 2 numbers. I'm going to say +3p and -5p. So it's important that you see that this is equivalent. You see 3p minus 5p is -2p, correct? That's why this part's important. It's important that we're not changing the size of the question. Okay, so now my question to you is, why is this better to factor than this? One more time?
There's a GCF.
Right before that, though. We will do GCF, but how many terms are there?
4 terms.
How do we normally factor 4 terms?
By grouping.
By grouping. And if you use the correct 2 numbers that meet these requirements, factor by grouping will work out perfectly. Group, group, GCF, GCF. Had to change that sign. And one thing I like about this method is because it forces you to factor by grouping, practice factor by grouping. In the end, you know that both these are supposed to have a p plus 1. They're supposed to be the same thing. And you can see we come out to the same answer. So, why I prefer this method over the other dozen ways you can learn factoring is it gives you more practice on factor by grouping, which typically you guys don't practice much, but I have seen it on practice ACT test. Indirectly, that forces you to practice GCF a couple times. This method always works, and in this method, right before you get your answer, you usually should have some confidence. If this is p plus 1 and this is not p plus 1, you know something's wrong before you write down your answer and circle it. If these are both p plus 1, then that's probably a pretty good sign that you're on the right track. Okay, so let me say that method 2 more times. So pretend like we did guess and check here. Either we couldn't figure out the right number combination, or maybe it just doesn't even factor. But at some point we say maybe it's quicker to just do product sum. So product sum wants me to find 2 numbers that multiply to whatever a times c is, and that's the question, that would be 10. There's a few different things that multiply to 10. I want to keep the ones that add up to b, which is 11. These don't add to 11, these don't add to 11, these don't add to 11, these do. Use these 2 numbers to switch this from 3 terms to 4 terms. Leave the 2v squared alone, leave the plus 5 alone, but instead of saying plus 11v's, we're going to use these 2 numbers, plus 1v plus 10v. And if you use those 2 numbers that meet these requirements, factor by grouping will work. So you should feel home free at this point. Group, group. If the middle sign's a minus, you need to change this sign. GCF, GCF. Almost done. Both of these are 2v minus 1. That's a great sign. What would the rest of my answer be? B plus 5. So it is often more time consuming than guess and check. But sometimes, if you just can't think of the right number combination to guess, sometimes it's just quicker to just jump into this product sum method. Okay, one more time. And notice on this question, we have a little bit of a help here. Again, I'm going to assume I tried guess and check and just pretend like it doesn't work. If I start to do product sum, it's easy enough to see that b is 66, but a times c is 9 times 21. It's a little bit harder to work with, right? And it's going to be a bigger number. So that's going to be harder to find 2 numbers that give you 9 times 21 but add up to 66. Keep in mind, I said this earlier, I'm saying this, I didn't remember to do this first period today, so I'm guilty of it sometimes too. If this has a GCF, your life is going to be a lot easier if you take out the GCF first. It's going to make all the numbers smaller and more manageable. These have a 3 in common, so you can just factor out that 3 and carry it along for the ride, and it'll be part of your answer, but that makes the rest of this a lot more manageable. Now a times c is 21 and b is 22. So I could list all the things that multiply to 21, but honestly the first thing I would try adds up to 22. So you can really stop as soon as you figure out that right number combination, and then make sure you know how to use it. We're going to rewrite this using these 2 numbers. It doesn't matter which one you do. It doesn't matter if you do plus k then plus 21k, or if you do 21k plus 1k. Factor by grouping handles all of that perfectly without your input. Then we could factor out then we can do grouping. Group, factor out a k, leaves behind a 3k plus 1. Factor out a 7, leaves behind a 3k plus 1. Great sign that those are the same. Can factor out that 3k plus 1, and then the other parts would be k plus 7. And then of course the 3 that I pulled out from the beginning. If you don't pull the 3 out at the beginning, you really should pull it out at the end. But pulling it out at the beginning, notice it makes all of these numbers smaller. It makes this a lot easier to do. It's certainly possible to do it the other way. In fact, I'll show you first period. I did it and it wasn't too terrible. 9 times 21 was 189. I found two numbers that multiplied to 189 but add up to 66. Just those bigger numbers took me a little more time, but then I could just jump straight into that, and then I had to remember GCF at the end. So if you don't like product sum method, that is perfectly fine with me. I do not mind if you have a method that you prefer more. Again, it's just that I don't know all the methods, nor do I bother to try to know every factoring method possible. I like this method because it always works. It reinforces GCF, it reinforces factor by grouping. You only have to learn a couple steps before you can get to the grouping anyway. And you've got the sign at the end. If these binomials are not the same, then you know something's wrong. So that's why I prefer that method. Okay, so flip over to the next page. Again, this doesn't really apply to us for the next few classes, but this is how this is going to be used for us in section 5.3 after Thanksgiving. How would you factor this question 1? One more time.
Difference of 2 squares.
Okay, it is difference of 2 squares. So how does it factor? Okay. How does 4 sine squared minus 1 factor? It's the same thing. It's the same exact thought process. 4x squared minus 1, 4 sine squared minus 1. Whether it's an x or a sine, this is still difference of 2 squares. You've got something being squared here. 2 sine times 2 sine gives you 4 sine squared. You've got something being squared here. It's 1. And difference of 2 squares always factors as a plus and a minus. The only difference is that these were x's and these were sine x's. 2x plus 1, 2 sine x plus 1. 2x minus 1, 2 sine x minus 1. If you can factor this, you can factor trig stuff as well. Okay, so what method would I need to factor question 2? Okay, GCF. They both have an x in common. We can factor it out. This is the same exact problem, but instead of x's, they're cosine x's. If they both have a cosine x, you can factor it out. So with x's, it's x times x plus 1. With cosine x's, it's cosine x times cosine x plus 1. The factoring is identical though. Just instead of x, it's sine x or cosine x. But no harder. Okay, just like question 2 started off with GCF, question 3 starts off with GCF. But even after GCF, it's got a difference of 2 squares. Sometimes you can do these methods more than once. And if you can see that on question 3, and question 3 over here is the same thing. It looks more complicated, but this also has a GCF of secant squared. What's left behind is still the difference of 2 squares. And then please note, everywhere there's an x, it's been replaced with secant x. That's the only difference. Still GCF and difference of 2 squares. Now, again, you don't have to get into this today because we're not doing section 5.3 today, but I just want to sidebar real quick just to remind you that usually when you factor, factoring is really just kind of a tool. Usually you use factoring to solve an equation. We're not solving equations today. But if you can factor in a set equal to 0, then where each factor equals 0 gives you solutions. So we will be doing the same thing in section 5.3. But instead of regular x's, they're going to be maybe cosine x's. You're still going to factor it the same way. You're still going to set each factor equal to 0 and solve. But unlike in algebra, where you've got your answer, in trig, we're going to have to use a little bit of unit circle. You're going to have to think about where cosine is 0 to get a couple answers, and cosine can equal 5. That's outside of the range of cosine. So this is what we will be doing when we come back. That's why this factoring, making sure that everyone's up to speed, is important. Okay, on to 4. So now it's a trinomial. So trinomial, I would always try guess and check first. X times x gives me x squared. Cosecant x times cosecant x gives me cosecant squared. Plus 2 times negative 1 multiplies to negative 2. Plus 2 times negative 1 multiplies to negative 2. Outer part of FOIL combined with inner part of FOIL gives me 1x. Outer part of FOIL combined with inner part of FOIL gives me 1 cosecant x. Instead of regular x's, they're cosecant x's. Otherwise, the same thing. Okay, and then now a is not 1, so maybe a little bit harder to do guess and check. If you have to get out product sum method or some other method, then please do. But if you can see why this factors this way, these are both signs. They're going to factor the exact same way. Everywhere there's an x, it would be a sine x, but identical logic behind it. That's why this factoring sounds like we're kind of off track here, but it does relate to trig. So it does carry over to trig. Okay, so on the back page, you've got 10 questions to factor. I know at least one of those does not factor, and I certainly encourage you to try to do all the GCF stuff. Maybe the difference of 2 square ones, those are a little bit easier first. On the trinomials, certainly try to do guess and check. Just make sure that you are checking them by foiling them. And any of them that you struggle to get, try the product sum method or try whatever method you remember from last year. So you've got the rest of class to put in a good effort on those last 10. I do not have a solution guide online because, again, I'd like you to check your work by multiplication. I'm giving you plenty of time to do that. And you guys have just about 45 minutes. So 45 minutes for 10 questions should be very manageable. So do that for me. I am asking you to put that in Google Classroom, and that will be it for today. We will practice some more factoring in the next day or two, and also start to sprinkle in a little bit of the semester test, but that is where we will be till Thanksgiving. Oh. Hey. Sure. Thank you. Elise, you checked out. Also, I will add one more piece of information here. When you guys are doing this product sum, one other method I like about this is, I just use this one as an example. You guys know that some stuff does not, oh, you can't even see it. Some stuff does not factor. Some stuff is considered prime. So, on this question that we did on your notes, if you try to do this with guess and check, and you guess something, and then it doesn't work, and then you guess something else, and it doesn't work, and you guess something else, and it doesn't work, and then you run out of guesses, you don't know what else to try, or you just spend all day guessing, it could be that it doesn't factor at all. This product sum method helps with that, because if you list everything that multiplies to A times C, and none of it adds up to B, then you know that it's not going to factor without just giving up, basically. So anyway, as you guys have questions, please let me know and I will help. And again, you should finish this up in class, so please put it in Google Classroom. If you somehow don't finish, if you need more time, as long as it's in Google Classroom before class on Monday. This is a B week, so it's the last time I see y'all this week. And you guys are welcome to, I don't know, you shouldn't be necessarily working in group because I want you to, there's only 10 questions, but you're welcome to compare answers, help each other out.
Mr. Townsend,
Yep.
could you help me understand the negative when it comes to the factor by grouping?
Mm-hmm.
Because, so we distribute like the negative, right?
Mm-hmm.
And then we take out, say, like -8. Wouldn't this turn to a positive one? Or
Well, I didn't take out a -8.
how did you do it?
Oh, okay, you squeeze in a plus sign here. I don't do it that way.
Hmm.
So right here, when you create these parentheses,
Yes.
what's the number in front of this parentheses?
1.
A positive one, right? And when you distribute +1, it doesn't change anything.
Mhm.
So this, with the parentheses, is consistent with what the original question was. It didn't change anything. But when there's a minus sign, this is like a -1.
Mhm.
And now, -1 to this is good, because this is supposed to be negative.
Mhm.
But it also goes to this because you put those parentheses in there, which makes this a -8, and that's not what the question was. The question wasn't for a -8. So you have to switch this sign so that when you distribute this negative to this, it goes back to being positive, which was the original problem.
Okay.
So this is the same thing as this. +1 distributed doesn't change anything. But these are not the same, right? Well, so when you write these parentheses in when you do factor by grouping, if that's a minus sign up front, What's wrong is now this sign. Because when you distribute this, you get a minus 3x. Well, that would have to be minus, but you get a minus 3x, which is fine. But now it's also going to this because of these parentheses that I put in the question.
Okay.
So that gives you a negative 5, but you need it to be a positive 5. So by switching this sign, now a negative times a negative keeps it consistent with what the original question was.
Okay.
So it's just that when you put in these parentheses, you might be changing the question. So if it's a minus sign, you've got to change the last sign.
Right. Thank you.
Yep.
We learned this last one was wasn't good, so
everyone was good at it and remembered it, we wouldn't spend any more time on it. Most people appreciate some more practice. Okay, again, you guys are more than welcome to ask me for some help. I know factoring is a lot easier for some people than others, but since we're going to be using it soon, try to give you a chance to get some practice in. Do y'all remember if Miss Polson did product sum method, or did she teach it a different way? She did product sum. What about Mr. Smith? Somebody go ahead, Mr. Smith last year?
No, I think he taught us this way.
Okay. Well, I'm not against any method that works, but since y'all have never heard of the washing machine method, you might want to look it up someday. It's pretty elaborate. Very, very inefficient. Okay.
Yes, sir.
And send it in.
Yep.
Great. Parent contact. But I can't take that off, so you'll have to pull that off. If you're not there. But they have to mark it Since this is kind of a short lesson, I will share with you, if you like puzzles, one of my favorite puzzles. But if you're frustrated easily by puzzles, you may not want to pay attention because I won't share the correct answer until the end of the year. So it is a puzzle that's possible, but it's a lot harder than it seems like. It's one where if you put 2 squares on top of 3 squares like this, you have to try to make one continuous line that goes through each line segment once. Not more than once, not less than once. So, without picking up my pencil so that it's continuous, like this counts as getting this, and then I've got this side, and now I've got those sides. These sides are considered separate, so you have to hit both of those. So that is not a solution because I missed this one. But there is a way to draw one line, one continuous line that goes through all of those. And it seems pretty easy, but again, it's pretty difficult. So but if it's going to bug you, then don't even try because I won't share my solution until the end of the year because I don't want to spoil it for anybody. But it's just kind of a fun thing to play with sometimes when you're done with class and you're just wanting to doodle or something.
You haven't started outside the box.
Either way, you can start inside any of the boxes you want. You can start outside. Up to you. But I promise it is possible. I would not, well, I would lie to you, but I would not lie to you and make you try all year before I told you the truth. And also, this is like an abstract representation of some real world problem. This guy had this real problem in real life, and he just represented it this way to try to solve it and see if he could figure it out. I don't like to tell people what the original real life problem was because then you can just Google search and see what people did to make it work. But if you think you have the solution, which every time people do think that they do, you can show it to me, but and I would confirm if it's correct, but also you should know if it's correct. I mean, it either does it or it doesn't. So also, it's not some weird trick where it's like where you go through this vertex and that counts as all the sides. That doesn't work. You can't like cross back over where you came in. That's not allowed either. You can cross the line. Like that's fine. I can cross it itself. Anyway, I have shared this puzzle with my classes almost every year that I've ever taught, and I think I've ever had one student who actually figured it out on their own. So,